In his 1981 novel, Neuromancer, author William Gibson imagined a near future when people with surgically implanted data ports could connect their minds directly to data communication networks. Gibson was the first person to call this cyberspace. That's no longer entirely science fiction. Today, we'll be talking about brain-computer interfaces. I'm Ricky, an engineer here at Mouser Electronics. Welcome to Need to Know, where we break down key technologies, engineering fundamentals, and the latest breakthroughs shaping science and innovation. For the longest time, the state-of-the-art with brain-computer interfaces, or BCIs, have been networks of electrodes that can be temporarily attached to one's head. Test subjects using rigs like this one have been able to move cursors on computer screens, control prosthetic limbs, fly drones, and even drive cars, simply by thinking about it. However, these BCIs are not always easy to use. Test subjects often need extensive training just to produce the exact brain activity patterns the system can recognize. The challenge is that the brain's electrical signals are both fast and faint. A single neuron's action potential lasts only 1 to 2 milliseconds, and in scalp electroencephalography, the voltages are typically just tens of microvolts. On top of that, signals lose 70 to 90% of their strength passing through bone and soft tissue. And with external electrodes, isolating the activity of a single brain cell is nearly impossible. Neuroscientists are pushing BCIs into a whole new phase. Not just sensors on your scalp. Take a look at these implants that go inside the brain. They are microscopic probes that listen to single neurons, and sometimes talk back. That's right, they can deliver precise electrical stimulation to targeted cells. The probes connect to a small lead that exits the body, usually placed near the nape of the neck. That lead runs to an external unit, basically a custom-built, high-power computer, processing the brain signals in real time. I know, it's experimental, it's invasive, but it's opening doors we've only dreamed about. Keeping all electronics inside the body is the safest option from a medical standpoint. So the ultimate goal is to implant a small computing unit along with a wireless radio inside the body. And of course, this must overcome challenges like safe wireless power delivery, thermal limits, and long-term biocompatibility. The health industry is already doing this with pacemakers. While some elements of a pacemaker are located within the heart, most of the electronics are housed in a larger unit that is implanted under the skin near the left shoulder. With these new BCIs, scientists are already turning raw neural signals into precise, real-world communication. Here is just one example. Imagine a person who has become paralyzed and can no longer speak. Phonemes are the individual sounds we combine to form words. There are 39 in English. Using a BCI, researchers mapped the brain signals that control the facial muscles for each of these sounds. Then they trained a recurrent neural network, or RNN, to predict which phoneme the person wanted to say by reading those muscle-controlled signals. Researchers report this model can be surprisingly accurate at predicting what the test subject is trying to say. In a brand new study published in the summer of 2025, researchers from Stanford University reported that the subject does not have to pretend to try to speak. Instead, merely thinking about the words, what the researchers call imagined speech, produces signals in a different part of the brain. These signals are much weaker, but they can be accurately interpreted by a neural network computer. Advances like this have already greatly expanded our understanding of how the human brain works, and ongoing research is pointing toward exciting medical outcomes, where challenges such as paraplegia, paralysis, and blindness could be overcome with a combination of neuroscience and electronics. To learn more about brain-computer interfaces, check out this article on our website. You can also explore our technical library, which has articles on a wide range of topics. And don't forget to subscribe to our YouTube channel to keep up with what you need to know.